at that point is also equal to the both LHL and RHL, then we say that the function is a continuous function. Okay, we will discuss some example later. So this is the meaning of, this is the definition of the continuity of a function at a point, okay, at a point A. And when the function is continuous at each and every point in its domain, then we call the function is a continuous function, okay. So that's the algebraic definition of the continuity. So let me take an example. I think all of you are visible on the screen. I hope that the screen is visible to all of you. So this is a very, very standard function, very well-known function. You might have studied in your 11th class. The graph, very familiar to all of you. So this is the graph of the Signum function, isn't it? The graph of the Signum function. What is the definition of the Signum function? F of x equal to x. Sorry, f of x equal to 1 when x is greater than 0. Okay? X is greater than 0 means just right side of 0, the function is always 1. And for values of x less than 0, the function is always negative 1. And at the point 0, the value of the function is 0. Okay? So very clearly, what you can observe in this graph, is there any break of this function? Of the any break in the graph of this function? Very clearly, we can observe that at the point 0, there is a break. You know? So very clearly, you can see the limit also. From the left side of 0, we are if x takes values from the left side of 0, the function always takes the value negative 1. You know? All points less than 0, the function value is always negative 1 everywhere. And from the left side of, right side of 0, from the right side of 0, if we approach. So I request all the participants to switch off your mic, okay? Please mute all of you. Already admitted, no? Okay. Okay. So I request all the participants to mute your mic, okay? So I am discussing the continuity of the function, the Signum function, okay? So very clearly, the left hand limit is negative 1 and the right hand limit is 1. So very clearly, the left hand limit is not equal to the right hand limit. LHL is negative 1, RHL is plus 1. So here itself, the condition fails. No? LHL not equal to RHL. So the point 0 is 0 actually. Okay. So when the LHL and RHL are not equal, there itself the condition fails, and we can conclude that the function is a discontinuous function. Okay, it's a very well-known function, a very standard function. Now you observe this graph. I hope that the graph is visible to all of you. So this is the graph of the function f of x equal to x if x is greater than or equal to 0, and x minus 2 if x is less than 0. Okay? F of x equal x if x is greater than or equal to 0, and f of x is x minus 2 if x is less than 0. So very clearly from the graph, what you can observe? What is the right hand limit of this function at the point 0? Very clearly we can observe in the graph there is a break at the point 0. Na? The graph is not continuous at the point 0. Very easily we can clearly observe from the graph itself. But algebraically, what is the right hand limit of this function at the point 0? I think it is very clear. From the right side of 0, the function is approaching to 0. When x is approaching to 0 from the right side, the function is approaching to 0. And from the left side of 0, if x is approaching from the left side, the function value is approaching to -2. Okay? So very clearly, the LHL is equal to -2, and the RHL, the right hand limit, is equal to 0. Okay? So very clearly, LHL and RHL are not equal, so the function is not continuous at the point 0. Okay? Now, sometimes we may not be able to identify the gap in a graph by our eyes. Okay? Always it is not possible to recognize whether there is a gap or not. So, at that time, we need our definition, the algebraic definition actually. Okay, you can see this graph actually. This graph looks like it's a straight line. You know? So this is the function actually defined by f of x is equal to x square minus 1 divided by x minus 1. X square minus 1 divided by x minus 1. In 11th class, you might have taken this example when studying the limit actually. Okay. F of x equal to x square minus x divided by x minus 1, or x not equal to 1. For x not equal to 1. So if I take the value at the point 0, what is 0, not 0, f of 1. What is the function value at the point 1? What is the function value at the point 1? If I substitute, what you will get? 1 minus 1 upon 1 minus 1, that is 0 by 0. And 0 by 0 is not a real number. That is called indeterminate, which is called indeterminate. So at the point 1, actually, the function has no value actually. The function is indeterminate. Okay. But in the graph, if you observe, at the point 1, you may not be able to find any gap there. So actually, there is a very, very, very negligible gap is there. So if I take a point on this line, okay, so I have taken a point on this graph actually, on this line. Now I'm moving this point. Everywhere you can see this point. Now what happens? Just if I reach at the point 1, suddenly the point disappear. Now you cannot find that point. Okay? Why? Because at the point 1, the function has no value. At the point 1, the function has no value. But if I move just the left side of 1, the function has value. If I move just the right side of 1, the function has value. Okay? Except at the point 1. When it reaches exactly at the point 1, the function becomes indeterminate, and you cannot find this point here because it cannot identify the value actually here. Okay, so the left side, everywhere the limit is actually 2. You can very clearly easily you can see that from the left side of 1, if x is approaching from the left side of 1, the function value is approaching to 2. And similarly, from the right side of 1, when x is approaching to 1, the function is approaching to 2 only. But at the point 1, the function has no value. Okay. So if I define this function in this way, f of x equal to x square minus 1 divided by x minus 1 if x not equal to 1, and that is equal to 2. Okay. If x equal to 1. Suppose my function, I have defined this function in this way. F of x equal x square minus 1 by x minus 1 if x not equal to 1. And at the point 1, I define a value. The function value is 2. Okay. Now let us see whether this function is continuous or not. So what is the LHL? What is the left-hand limit here? Left-hand limit means limit of x tends to 1 minus f of x. That is limit x tends to 1 minus of. From the left side of 1, what is the function actually? From the left side of 1 and right side of 1, the function is same only actually. The function is x square minus 1 divided by x minus 1 only. Whether in the right side of the 1, in the left side of 1, the function is same actually. Okay. So actually there is no need of any finding the LHL and RHL separately. So anyway, the LHL is limit x tends 1 minus f of x, and this limit can be easily evaluated. You know the techniques of evaluating the limit. For evaluating the limit, there are different methods. Some formulas are there, or we can factorize. No? So this is same as limit of x tends to 1, x plus 1 into x minus 1 divided by x minus 1. X minus 1 cancel. So what is remaining is x plus 1. You put x equal to 1. So you will get the left-hand limit is equal to what we have observed in the graph. Just the left side of 1, the function is approaching to 2. You know? And from the right side of 1, also the function is approaching to 2. So the left-hand limit is actually 2. Similarly, the right-hand limit. There is no difference in finding the right-hand limit here because the function is same. Anyway, sometimes we need to find the LHL and RHL separately, depend upon the function actually. Okay. So here both sides the function is same. So at a time also we can evaluate the limit. Anyway, the same thing only. Limit of x tends to 1 plus of same thing. X plus 1 will be remaining. So only the thing is that x is approaching from the right side of what? 1. That's all. Okay. So 1 plus 1, that's equal to 2. So you can see that the right-hand limit is also equal to 2. Okay. So left-hand limit is 2, right-hand limit is 2, and the function, the given definition is the value of the function at the point 1 is also 2. That means every LHL, RHL, and the function value all are equal. So what is the conclusion? LHL equal to RHL equal to the value of the function at that point, each equal to 2 actually. So that means the limit of the function is equal to 2, and that is equal to f of 1 also. So that means this function satisfies this condition. Limit of f of x, x tends to 1 is equal to f of 1. Okay. Limit of x tends to 1, f of x is equal to f of 1. So this is a continuous function. Clear? So same function, suppose the same function, if it is given, the definition of the function, if it is given, for example, at x equal 1, suppose the given value is 3. Okay. At x equal 1, I have defined the function value as 3. In place of 2, the function value may be given as 3. Then what is the conclusion? So LHL will be 2 only. RHL also will be 2. But the value of the function, what is the value of the function at the point 1? We have defined it as 3. That means LHL and RHL are equal, but the value of the function is not equal. at that point. Okay, so in that case, the function is not continuous. In the second case, LHL and RHL are equal, but the value of the function not equal to the f of 1. Okay, f of 1 is given as 3 in the second case. So in the second case, this function is not continuous at the point 1. Clear? Okay, let us take another example. F of x equal to x square if x greater than or equal to 1. Okay, and x by 2 if x is less than 1. So let us check the continuity of this function at the point 1. So what we have to do is find the LHL. So what is LHL? Limit of f of x, x tends to 1 minus. We write x tends to 1 minus, that stands for the LHL. Okay. So limit x tends to 1 minus f of x means here function has two branches. Okay. For greater than 1, the function is x square. Greater than or equal to 1, the function is x square. And for less than 1, the function is x by 2. Okay. So we have to take the x by 2. No, x is less than 1 means the function is x by 2. Okay. So limit of x by 2 where x is approaching to 1. That means 1 by 2. Okay. So the limit, left hand limit is 1 by 2. Now let us find the right hand limit. Right hand limit means limit of the function as x approaches to 1 plus. So here x is approaching 1 from the right side of 1. Okay, right side of 1 means we have to say the definition for x greater than 1, the function is x square. That means limit of x square, x tends to 1, and that is very clearly the value is equal to 1 only. So what we can observe, LHL is my 1 by 2 and RHL is 1. So both are not equal. So very clearly the function is not continuous at the point 1. Here LHL and RHL both are different. So the function is not continuous at the point. So this is the idea of it. Okay. Now to evaluate the limit, yeah, to do the problems of continuity, you need to know some standard formulas are there. Some standard formula, standard limits. Okay. So everybody has to remember those formula. Depending on the question, we have to apply that formula. Okay. For example, some trigonometric function may come. Then we need to remember a trigonometric formula. From trigonometry, we have a standard limit. That is limit of sin x by x as x tends to 0 is equal to 1. Okay. From algebra, we have a standard limit. Limit of x raised to n minus a raised to n divided by x minus a as x tends to a. And this limit is equal to n into a raised to n minus 1. And another standard limit from exponential function, limit of e raised to x minus 1 divided by x. X tends to 0, that is equal to 1. And we have another formula from logarithmic functions. Limit of log of 1 plus x divided by x, x tends to 0, that is equal to 1. So these are the standard limits which are required for evaluating the limits. Okay, to deal with the continuity problems, you should by heart all this formula, and these are required laterwards also, afterwards also. Okay, and this is the special means particular case of another formula. We have a general formula, limit of a raised to x minus 1 divided by x, x tends to 0. In place of e, there is another constant, generally a. So the answer is log a. Okay. So this formula is a special case of this formula. Okay. If I replace a by e, you will get log e, and the log e means the value is 1, like that. Okay. So please remember the standard limits for evaluating the problems involving the continuity. For example, some function may come like this. Evaluate, check the continuity of the function given by sin x divided by 2x if x greater than 0 and e raised to 2x minus 1 divided by x if x less than or equal to 0. Sorry, less than 0 only, okay? Only strictly less than 0. And also, the value may be 2 at the point x equals 0. So function is given like this, okay? For x greater than 0, the function is sin x by 2x. For x less than 0, the function is e power 2x minus 1 divided by x. For x equals 0, the function is 2. So check the continuity of this function at the point 0. So what we have to do is the same thing. Find the LHL. So LHL means limit of x tends to the point 0 here, 0 minus, okay? Limit x tends to 0 minus f of x. So 0 minus means which function we have to take. That is the problem. That is only the thing we have to remember. There are different branches for this function. So for less than 0, what is the given function? E power 2x minus 1 divided by x. So while choosing the function, we have to be careful, okay? For less than 0, the function is e power 2x minus 1 divided by x. So for LHL, we have to consider that function only, okay? So limit x tends to 0, e power 2x minus 1 divided by x. This is we need to evaluate. For this, we have to remember the previous formula, what I have told you just now, okay? So in that formula, it was like this, e power x minus 1 divided by x, e power x minus 1 divided by x. But here, e power 2x is there. So please see, e power 2x is there. So we need to modify, okay, to get in the standard form. For that, what we have to do is limit x tends to 0, e power 2x minus 1 divided by, we write 2x. We require 2x in the denominator. So we write 2x. To balance it, we multiply 2. Okay. So that means if you apply the limit for the first part, this is in the standard form. Okay. Whenever x is tends to 0, the 2x also tends to 0. So we can apply directly the formula in the first part. So that is 1 actually. And 2 is a constant. So 1 into 2 means you will get 2. Okay. So the left LHL, the answer will be 2. Similarly, find the RHL. For RHL, you see the function sin x divided by 2x. Sin x divided by 2x. So limit of x tends to 0 plus x is approaching 0 from the right side of 0. Remember, right side of 0 means greater than 0. The function is given there as sine x divided by 2x. So divided by, actually the formula is sine x by x. In our standard limit, the formula is sine x by x. Here sine x by 2x, but 2 is a constant. So that can be taken outside, okay? The 1 by 2 can be taken outside. So 1 by 2 into limit of sine x by x means the standard limit, the value is 1. So that means the RHL, you will get the value is 1 by 2. Okay. So what we can conclude from here itself, LHL is 2 and RHL is 1 by 2. Both are not equal. So this function is not a continuous at the point 0. Okay. So that's about the continuity of a function at the point. Okay. We will discuss more problems in the later session. So this is the continuity of a function at a point. So when we say a function is continuous, if it is continuous at each and every point in its domain, okay, throughout its domain, if it is continuous, we say that it is a continuous function. Okay, now we have some standard results, theorems on continuity. All those theorems, just we have to understand only. Sum of two continuous function is again continuous function. Product of two continuous function is again a continuous function. Difference and quotient of two continuous functions are again continuous functions. Okay, all these things are some general properties. Just you remember, these points are not important for the examination purpose. Okay, for examination purpose, some problem will come like this. Check the continuity of the function at some point, indicated points at 0, at 2, or like that. Okay. And we have some standard other result also. All polynomial functions are continuous. All polynomial functions are continuous. And all trigonometric functions are continuous. All the trigonometric functions are continuous in its domain, wherever it is defined. Okay. All these points you just keep in your mind. All those points are not required for directly, means for solving problems. Direct problems will not be coming. Prove that sin x is continuous, like that. Never, the question will never ask actually. Okay, but these properties, these results are required for doing some other problems when we go for differentiation, etc. We record their properties. Okay, so please remember. Now we have some standard functions also. Mod x, greatest integer function. Signum function we have already discussed. The signum function. Now we have mod x. What is the continuity of the function mod x? Mod x is also one of the standard function. Okay, the graph, everybody knows the graph of mod x. It is V shape, and the definition is like this. Mod x, the definition is f of x equal to x if x greater than 0, and 0 if x equal to 0, and minus x if x is less than 0. Means all positive values of x, the function is x. And 0, the function is 0 only. And for all values of x less than 0, the function is minus x. So this is the graph of the mod x. So what we can observe from the graph? Is it a continuous function? Very clearly, you cannot see any break here. By our direct observation, there is no break actually here. But anyway, we can check. There is a possibility if it is not continuous, discontinuous, only the chance is at 0 only, because 0, you can find a turning point there at the point 0. Let us check the continuity at the point 0. So what is the limit? X tends to 0 minus f of x. LHL. If we evaluate the limit at the point 0, means LHL, x is approaching 0 from the left side of 0. So what we have to take the function for less than 0, the function is minus x. Isn't it? For x less than 0, the function is minus x. So we have to take the f of x as minus x. X is approaching 0 from the left side of 0. That means limit of minus x, that is equal to 0 only. And RHL. RHL equal to limit of f of x tends to 0 plus. That is equal to, from the right side of 0, the function is x only. Limit of x as x tends to 0, x is approaching 0 from the right side of 0, that is the 0 plus meaning, okay? So the value is equal to 0, okay? So LHL equal RHL, and the value of the function at the point 0, the value of the function at the point 0, that is also 0. From the definition you can see, okay? At x equal to 0, the function value is 0. Okay, LHL is 0, RHL is 0, the function value is also 0 at the point 0. That means the function is continuous at the point 0. Okay, so mod x is a very important example actually. When we discuss differentiability, there also it will come. Okay, there is a connection between continuous function and a differentiable function. Okay, at that time we will discuss again mod x about the differentiability. Okay. Now the greatest integer function. The greatest integer function. What about the greatest integer function? So let me plot the graph of the greatest integer function. Okay. So you can see this is the graph of the greatest integer function. This is also one of the standard function. You are familiar, isn't it? So very clearly from the graph, we can observe that this function is discontinuous. Okay, the function is not continuous. Now tell me, what are the points where the function is discontinuous? The point of discontinuity of this function. What are the points where this function is discontinuous? Very clearly, the integral points, the integral values, integers at the point 1. At the point 1, what is the left hand limit? At the point 1, if I check the left hand limit, what is the left hand limit of this function at the point 1? Very clearly from the graph, we can see that from the left side of 1, the function value is everywhere 0 only. Isn't it? From the left side of 1, this point, left side of 1, the function value is 0 only. So left hand limit is 0. Isn't it? And right side of 1, just if you move the right side of 1, what is the right hand limit? For example, 1.1. If I take 1.1, x is 1.1, the image is 1. No? If I take 1.01, the image is again 1. Okay, so everywhere in the right for the right side of 1, the function value is always 1 only. So right hand limit is 1 and left hand limit is 0. So very clearly at the point 1, it is not continuous. Similarly, if you take any integral point, if I take the point 4, for example, at the point 4, what is the left hand limit? For example, if I take 3.9, if I take 3.9, what is the image? 3 only, you know. 3.9 means the image will be coming here. 3.99 means again somewhat closer to 4. Again, the value is 3 only everywhere. You know, in between 3 and 4 up to 4, less than 4, the value is only 3 only. Okay. Now suddenly, if I move the right side of 4, what you can see? The function jumps to 4, na? So right hand limit is 4. Everywhere on the right side of 4, the function value is 4 only. So the right hand limit is 4, but the left hand limit is 3. That means the left-hand limit to right-hand limit both are not equal, so function is discontinuous at the point 4 also. So everywhere, every integral point, the function is discontinuous. Very clear? We can algebraically also, we can write this one, okay? Sometimes the question may ask, prove that the greatest integer function is discontinuous at all integral values. So this is the notation for the greatest integer function. Yeah. Okay. So in order to check the continuity at integral points, we choose any point generally, any integer. We cannot check at each and every point one by one, at 1, at 2, at 3, like that we cannot do. So we take arbitrary, an integer, arbitrary value, that is C. Okay. Now let us evaluate the left-hand limit at the point C. What is the left-hand limit of this function at the point C? That is x tends to C minus. We write x tends to C minus. It indicates that x takes values very close to C, but from the left side of C. Okay. X takes values from the left side of C. So what will be the left-hand limit then? So if I take the point 2, for example, 2, for example. So left side of 2 means 1.9. 1.9, the image will be 1. 1.99, the image will be 1 only. So if I take the point 2, the left-hand limit is 1. If I take the point 3, the left-hand limit will be 2. So like that, if I take the point C in general, in integer, then the left-hand limit will be C minus 1. Okay. That's the definition of the greatest integer function actually. And the right-hand limit. What is the right-hand limit of this function at the point C? We will say x tends to C plus f of x. So what is the limit? For example, if I take the point 2, right side of 2, just right side of 2, 2.1, the image is 2, 2.01, the image is 2, like that. So if I take any point C, the right-hand limit will be C only. So very clearly, left-hand limit is C minus 1, right-hand limit is C in general. So both are not equal though. So the greatest integer function is discontinuous at all integral values, at all integers. Okay. So with these points, I will move on to the next our chapter, differentiation, differentiability. Okay. So we are going to discuss what is meant by differentiability of a function at a point. Actually, continuity and differentiability both are connected together. Okay. Continuity is an essential property required for differentiability. There's a strong relation between differentiable function and continuous function. And differentiability also you have studied earlier in 11th class, and also you have studied in your 12th class also. Okay. So definition, everything everybody knows. So I will just mention. So differentiability also defined at a point only, just like continuity. Okay. The derivative of a function at a point A. So everybody knows the definition. It is limit of f of a plus h minus f of a divided by h as h tends to 0. Okay. F of a plus h minus f of a divided by h, where h is a very small increment. What we say, h is a very small quantity. Yeah, h is called an increment to a. So where this limiting value, if this limit exceeds So derivative exits at the point A means this value must exist finitely. Okay, this value must exist finitely. So when we say this limit exits, means the left hand limit and the right hand limit both must exits and both must be equal. Then only we say that the function is differentiable at the point A. Okay. So in this definition, both the limits are included. Okay, LHL and RHL. Actually, LHL we write left-hand derivative. Left-hand derivative. This definition is very important because recently in the last year board exam, there was a case study question based on this definition, LHL and RHL. In the recent term 1 exam, also the same question what we have asked in the board class, last year board exam, the same question was there in the term 1 exam question paper also. Okay, so please remember this definition very carefully. So left-hand derivative of the function at the point A, we write L f dash A, and that is defined as limit of f of A minus h minus f of A divided by minus h. H tends to 0. Okay. Here the h is approaching 0 from the left side of 0 actually. I will explain geometrically also. Please wait. And the right-hand limit, right-hand derivative, actually, right-hand derivative is defined as limit h tends to 0, f of a plus h minus f of a divided by h. So this is the left-hand derivative, and this is the right-hand derivative. If both values exits finitely and both are equal, then only we say that the function is a differentiable function at the point, whatever, at the point A. A means at the point A. Okay. So left-hand derivative, right-hand derivative, both must be equal. Both must exits and both must be equal. Then only we say that the function is a differentiable function at that point A. And also, if the function is differentiable at every point, we say that it is a differentiable function, just like continuous function. Okay. If it is differentiable at each and every point in its domain, then we say that the function is a differentiable function. Okay. So this definition you have to understand very carefully, and we have to use for doing problems. Okay. In case study last year, I told already, last year asked this question. In the term 1 exam also, some question was asked. Both the definitions are given in the question itself. Just you have to evaluate the left derivative, right derivative based on that given function. Okay. Actually, what is the meaning of this derivative? What is the geometrical meaning of this derivative? This expression has some geometrical interpretation actually. That is very, very important actually for the next chapter, application of derivatives. Okay. In that chapter, we require that definition actually, that meaning actually, the geometrical interpretation of the derivatives. Okay. So just I will show a presentation. If anybody want to ask anything, you can ask also. Okay. You can unmute your mic and okay. I hope that this presentation is visible. Okay. I would like to show the geometrical meaning of the derivative. Okay. Algebraically, okay, what I have written, everybody have seen, and you also knows already. So what is the meaning of the derivative actually? Okay. So you can see a graph actually here. It is the parabola actually. The function is also what I have taken is 0.4. F of x is 0.4 x square. Any function. Just for example, I have taken f of x is 0.4 x square. Okay. Now, I am going to find the derivative of this function at the point 2. Derivative of the function at the point 2. All of you know how to find the derivative of any function, okay? You can also evaluate the value directly in your mind also actually. What must be the value actually? 0.4 x square is the function actually, 0.4 x square. So derivative must be what? 2 into 0.4, that is 0.6. At the point 2, I'm telling, at the point 2. Okay, at the point 2 means 0.8 into 2 must be the value. That must be 1.6 actually. You know the derivative, how to evaluate and everything. So what I am going to show, what this 1.6 indicates geometrically. Okay, we can evaluate the derivative of any function at any point. We know every method we have studied actually. Okay, so what it indicates geometrically, what is that value actually? Okay, so geometrically, let us see. Okay, you can see a function and so at the point 2, I am evaluating the derivative at the point 2. Okay, so you can see the h value, f of a plus h means the h value. Now h is 0.3. In the graph, means in the screen, you can see f of 2 plus 0.3 minus f of 2 divided by 0.3. That is actually f of a plus h minus f of a divided by h in this case. Now h I will again reduce. H tends to 0. What I am doing is I am giving values for h that is very close to 0. H is approaching to 0. That's the meaning. H is approaching to 0 means h takes values very close to 0. Okay. So h is 0.2. Sorry. 0.2 now. Okay. H is 0.2. So what we can observe in the graph, you can see a line which is passing through the point 2 comma f of 2 at the point D. Okay, 2 comma f of 2 actually this one, and the second point B, that is a point actually represented by f of a plus h comma a plus h comma f of a plus h. So when h is approaching to 0, what you can see, that line passing through these 2 points are coming near to that blue line. And you can see one blue line is also there. Okay, when h is approaching, now you see h is exactly 0. H is exactly 0. In the right side on the screen, you can see f of 2 plus 0 minus f of 2 divided by 0 means 0 by 0. 0 by 0 is called actually indeterminate. Okay, but at this time, what we can observe in the graph, that previous line, now this line, you can see that line is falling on that blue line. And what is that blue line? That blue line is actually a tangent line at the point x equal to 2. Okay, at x equal to 2, the blue line is a tangent to this parabola. Clear? So when x is very, very close to 0, yeah, very, very near to 0, the previous line becomes a tangent tangent at the point 2. That is the meaning of the right hand limit actually. Okay, this is the right hand limit idea. Now I will take the left hand limit. Now this is the left hand limit. Okay, h is minus 1.4, h is minus 1.2, minus 1.1, minus 1. So h is approaching 0 from the left side of 0. That's the meaning. Left hand limit. H is now 0.7, minus 0.7, minus 0.5, minus 0.3. So what you can observe, in the graph, that line is approaching to the blue line. You know? Again, you can see when h is very, very close to 0, you can see the both lines are coinciding. So when h becomes 0, the line must exactly fall on the blue line. So it means it becomes a tangent. It becomes a tangent at the point, that point, the point is actually 2 here. Now, what is the slope of this tangent actually? If I measure the slope of this blue line, you can see what is the value actually. You can see the slope is displayed directly on the graph actually. The slope of the tangent, the blue line is a tangent at the point 2, and the slope of the tangent is actually how much? 1.6. And what is the derivative at that point also? That is also 1.6. Okay. So geometrically, that is the value of the slope of the tangent at that point. Okay. If you draw a tangent to a curve, to a function, at a point, the tangent must have a slope. Okay. If there is a slope of at that point, that value is called the derivative actually. Okay. So that's the meaning of the geometrical meaning of the derivative. So when we are finding the derivative of any function at any point, what we are getting is a numerical value, and that value is the slope of the tangent to that function at that particular point. Clear? So when we say a function is differentiable, means what's geometrical meaning? The slope of the tangent exits at each and every point on the graph of the function. Okay. The slope of the tangent exits at each and every point on that particular function. Then we say that the function is a differentiable function. That's the meaning of the derivative geometrically. Clear? Any function. So let me take another function. Let me plot sin x. Sin x is a very well-known function. Okay. I think the graph is very visible to all of you. Okay, this is the graph of sine function. Okay. For example, I take a point at the point 0, for example. At the point 0. Let me draw a tangent at this point. Let me draw a tangent at this point. Okay. To the sine function. Okay. Now the tangent has appeared there. Okay. Now let me calculate the slope of this tangent. Slope of this tangent at this point 0. So what you can observe? On the graph also very clear, the line is a very standard line, y equal x. You know? So the slope of the line is already displayed here. It is 1 actually. Okay. So this 1 actually represents what? This is the value of the derivative of the sine function at the point 0. Okay, you know what is the derivative of sine function? Derivative of sine function is cos x. Derivative of sine x is cos x. 11th class you have studied, and now also you have studied. Derivative of sine x is cos x. And we have calculated the derivative at the point 0. The point is 0 here. That means cos 0. Derivative of sine x is cos x, and the point is 0. That means cos 0. So what is the value of cos 0? Cos 0 is 1. So cos 0 is 1. So that is the derivative of the sine function at the point 0. So that can be very easily clear in the graph of the sine function. Okay. So if I move this point, I take another point. Okay. Box here too. Okay. Okay, let me take another point. Okay. And I am going to draw the tangent at that point. At this point, I will draw a tangent. Okay. Sorry. Okay. Now you can see the tangent is appeared there. So this point is nearly maybe 1.5. Okay, 1.5. At that point, you can see the tangent, and let us calculate the slope of the tangent at this point. So the value may be mine 0.07. The value is actually 0.07. So this is the derivative of the sine function at that particular point, maybe 1.5 nearly. Okay. So if I move this point, you can see the tangent is changing and slope is also changing. So everywhere you will get a value actually. Wherever I move this point, everywhere there exists a tangent and the tangent has a slope also. Okay. So that means the function is differentiable. Sin x is a differentiable function at each and every point. Okay. So geometrically speaking, differentiable means the tangent must exist uniquely at that particular point. Everywhere, if the tangent exists uniquely, then we say that the function is differentiable. Okay, that's the geometrical meaning of differentiability. The function will be a smooth function also. Okay, now let us check the differentiability of the function mod x. Okay. Okay, before that, I think we have to take some break. So we'll take a 15 minutes break. And after that, we will come back and discuss the remaining parts.
entrepreneur become the poorest very important, you know.
Using this screen.
I will do. Okay. Okay, na?
You can just switch to that screen.
Okay, children. Welcome back. So far, we are discussing about the differentiability of a function. So I have shown you the geometrical interpretation through a graphical presentation. So geometrically, the derivative of a function at a point is the slope of the tangent at that point. Okay, actually, the ratio, actually what we are taking the f of a plus h minus f of a divided by h. That is actually represent the slope actually. Okay, f of a plus h minus f of a means the difference of the y coordinates, y2 minus y1 like that. And the denominator, that is h, means a plus h minus a. And that is nothing but the difference between the x coordinates. So it is nothing but, this ratio is nothing but y2 minus y1 upon x2 minus x1. And you know that is a slope of a line passing through the 2 points, a f of a, and the second point is a plus h comma f of a plus h. Okay. So this ratio always represents the slope of a line. And when h is approaching to 0, approaching to 0, this ratio becomes a approaching to a particular number. Okay, and that number, that value is the slope of the tangent. When h is approaching to 0, that line becomes a tangent. So the derivative becomes the slope of the tangent at that particular point. Okay. Now you see here in this graph, in the screen, you can see the h is 0.1. 2 plus 0.1 means h is 0.1. So it is f of 2 plus h minus f of 2 divided by h. H is 0.1. And what about the ratio? 0.16 divided by 0.1. That is 1.64. 1.6164 means that is very near to 1.6. Okay. So if I again make h smaller, means very close to 0, then again this ratio will approach to more closer to 1.6, more closer to 1.6. And the limiting case, in the limiting case, the value will be 1.6. Okay, so that is the meaning of the derivative. Now I am going to take an example, a very important example actually. It is the mode function. F of x equal mod x. We have already seen this function in continuity. This function is a continuous function. Okay, it is continuous everywhere. Okay, now we are going to check the differentiability of this function mod x at the point 0. What about the derivative of this function at the point 0? So let us find the left-hand derivative at the point 0. You know the mod x function, the graph also everybody knows. The mod x has a turning point at the point 0. No, 0 is a turning point. So at that point, we need to check the differentiability. So let us consider the left-hand derivative at the point 0. By definition, this is a limit h tends to 0, f of 0 plus h, f of a plus h means f of 0 plus h minus f of 0 divided by h. That is equal to limit h tends to 0, f of 0 plus h. F of 0 plus h means f of h. F of h means, you see the definition of mod x. Okay, our function is mod x, and mod x, the definition is mod x equal x if x greater than 0 and 0 at the point 0 and minus x if x is less than 0. This is the definition of mod x. So f of h means mod h. F of h stands for mod h. So mod h, we have to take which value? Mod x equal x if x is positive, mod x equal minus x if x is negative. So mod h means it may be either plus h or minus h. No, one of them, either plus h or minus h. But here we are taking the left-hand derivative, means from the left side of 0. From the left side of 0. That means f of h, yeah, mod h must be minus h. So there we have to be careful. Okay. Left-hand derivative means left side of that point is 0. So left side of 0 means f of h means minus h. So minus h and f of 0 means 0 and divided by h. So limit of minus h by h. What is minus h by h? Everybody knows the value is -1. So limit of -1. Limit of -1 means -1. So that means the left-hand derivative at the point 0 is equal to -1. Clear? Now we will see the right-hand derivative. What is the right-hand derivative at the point 0? So I write RF dash 0. Right-hand derivative, definition, limit f of zero plus h minus f of 0 divided by h. And that's equal to from the right side of 0, f of h is h. Now f of 0 plus h means f of h, and f of h means h only. So limit of h tends to 0, limit h tends to 0, what you will get? H by h, and h by h stands for 1, and limit of 1 is equal to 1. That means the right hand derivative is 1. So left hand derivative is -1 and right hand derivative is 1. So both the limits are not equal. So the function is not differentiable at the point 0. Okay. So mod x is a very standard, well-known example of a function which is continuous but not differentiable. Continuous but not differentiable. Okay. So function may be continuous but not differentiable. Okay. So there is a connection between continuity and differentiability. Actually, in fact, there is a theorem. Okay. The proof of the theorem is not needed for you, but the theorem says that all differentiable functions are continuous. All differentiable functions are continuous.
Sir, I have
But the
doubt.
converse is not.
Sir, in
Okay.
left hand derivative,
The converse is not true means all continuous functions may not be differentiable. Okay. For example, mod x. Mod x is continuous, but it is not differentiable at the point 0. Okay. Mod x is a very standard example of a function which is continuous but not differentiable. But all differentiable functions are continuous. Okay, the proof is not required for you. That's why I'm not telling about that. But the property, the result, you must remember,
I have
all the
doubt, sir.
differentiable functions are continuous. Okay.
Sir, we have doubts, sir.
So D implies C. I can say like this. Differentiability implies continuity. Differentiability implies continuity. But C does not imply D. Continuity does not imply differentiability. The example is mod x. Mod x is continuous but not differentiable. Okay, so that's a very important result, a important theorem. All differentiable functions are continuous, but the converse is not true. Example is mod x. So like that, if I take mod x minus 1, another, if I want to give another example of a same kind of function, I can take mod x minus 1. Mod x minus 1. The graph also you must be familiar. Mod x minus 1 and mod x. What is the difference in the graph? Only the sharp edge may shift. Okay. Mod x, the sharp edge was at the point 0, and mod x minus 1, the sharp edge point will be at the point 1 only. Okay. So the graph may be like this. Will be like this only. At the point 1, you can observe a sharp edge. Okay. So geometrically also speaking, a function, if a function, the graph contains a sharp edge, at some point, the function is not differentiable. Okay. So differentiable function means a smooth function. Okay. There should not be any sharp edge on the graph. Okay. So that's why if a function has some break in the graph, suppose there is a break, then very clearly it is not continuous. Okay. And also it is not differentiable, because at this end point, at this end points where there is a break, at that point it is not differentiable. Okay, we cannot draw a unique tangent at that point. Geometrically speaking, at that end, that breaking point, that break, there does not exist a unique tangent. Okay, in that way also we can say. That's why continuity in essential quality required for differentiability. Okay, but if it is continuous also, not sure it is differentiable.
Sir, copy.
Okay, keep the. But if it is non-continuous, definitely it is not differentiable. Clear? Continuity does not implies differentiability. Differentiability implies continuity. And non-continuity implies non-differentiability. If a function is not continuous, means clearly it is not differentiable also. So please remember these points in your mind. Okay. Anyway, so I am discussing about mod x minus 1 at the point 1. At the point 1, you can see a sharp edge. Very clearly, the function may not be differentiable at the point 1. Okay. So let us check algebraically. For example, suppose we have to do algebraically. So let us find the left hand derivative at the point 1. The definition of left hand derivative, f of 1 minus h minus f of 1 divided by minus h. H tends to 0. And that's equal to limit of h tends to 0, f of 1 minus h. F of 1 minus h stands for left side of 1. 1 minus h stands for left side of 1. And left side of 1, the function is what? You know the mod x definition. Mod x minus 1 is also like that only. It is minus of x minus 1 if x is less than 1. And it is x minus 1 if x is greater than or equal to 1. That means for less than 1, for x less than 1, we have to take the branch minus of x minus 1. Okay. So here it is 1 minus f of 1 minus h. F of 1 minus h means 1 minus h stands for less than 1. Okay. So it should be minus of 1 minus h and minus what is f of 1? So 1 minus h minus 1. Okay. Minus of x minus 1 is here. Okay. So 1 minus h minus 1. You should be very clear, cautious while writing. Okay. The function is mod x minus 1 is minus of x minus 1. Minus of x minus 1. So in place of x, it is 1 minus h here. Okay. In place of x, it is 1 minus h. That means minus of 1 minus h minus 1. X, in place of x, you have to write 1 minus h. In place of x, you have to write 1 minus h. So minus of 1 minus h minus 1 minus f of 1. F of 1 means 1 minus 1, that is 0. Okay. So simplify. So remove the bracket. So inside the bracket, you can see 1 minus h minus 1. 1 cancel. Remaining is minus h. Okay. Inside the bracket, minus h will be remaining. And in outside, there is a minus actually. So minus of minus h means plus h. Okay. So normal simple calculation only. So limit of h divided by minus h. H tends to 0. That's equal to minus 1. Okay. Now let us find the right hand limit. Right hand limit. Limit of f of 0 plus h minus 3. F of 1 plus h. Sorry. The point is 1. So we have to write f of 1 plus h minus f of 1 divided by h. H tends to 0. Okay. This is the right hand derivative at the point 1. Right hand derivative at the point 1. And by definition again, limit of h tends to 0, f of 1 plus h. Again, you see the definition of mod x. Okay. 1 plus h stands for 1 plus something. H is a positive quantity. So 1 plus h stands for right side of 1. So right side of 1, the function is, by definition, mod x minus 1 is x minus 1. Mod x minus 1 is x minus 1. So f of 1 plus h means mod 1 plus h. So mod 1 plus h is 1 plus h only. So 1 plus h. Okay. 1 plus h minus 1. F of x is x minus 1. Remember, f of x is x minus 1. Minus f of 1 is 0 divided by h. Okay. So 1 plus h minus 1 minus 0. So 1 plus h minus 1 means h. So h by h. H by h means 1. So limit of 1 means 1. So left hand derivative is again here minus 1. Right hand derivative is 1. So very clearly both are not equal. So mod x minus 1 is not differentiable at the point 1. So graphically also it is very clear. I already told you. Very clearly at the point 1, we can observe a sharp edge at the point 1. Okay. So that's why it is not differentiable at the point 1. Okay. Similarly, you can prove mod x minus 2, mod x minus 3 like that. So mod x minus 1 just we have done. No? In the term 1 exam, there was a question actually. This is an example of a function. There are 4 options: continuous and differentiable, continuous but not differentiable like that. Okay. So the option was, correct option is what? This function is continuous at the point 1, but not differentiable at the point 1. Okay. Continuous but not differentiable at the point 1. Similarly, if I take a mod x minus 2, very easily you can give the answer. This is an example of a function which is continuous but not differentiable at the point 2. Okay, same procedure. Left derivative again, it will be negative 1 only. Right derivative again, it will be 1 only. LHL, RHL. LHL will be negative 1, RHL will be positive 1. Both are not equal. So it is not differentiable at the point 2. At the point 2, remember. Okay. All other points it is differentiable, but at the point 2, yeah, at the point 1, etc., it is not differentiable. If I take mod x plus 1, modulus of x plus 1. Now you see all the graph of mod function is all of the same type only, same nature. Mod x plus 1 means it will be shifted 1 unit backward. No? The negative 1 will be the sharp edge. Okay. The sharp edge will be shifted to the left side at the point negative 1. So graph, the shape is not no change actually. Okay. So very clearly the left side derivative is negative 1 and right side derivative is positive 1, because you know derivative means the slope of the tangent actually. So negative 1 right side means there is a line whose slope is very clearly 1. This line is y equal to x actually. Means y equal to x plus 1 right side. Okay. And left side is y is equal to minus of x plus 1. So anyway, the slope is slope of the tangent is negative 1 and positive 1. So all these kind of functions, the method is same only. Okay. Left derivative, right derivative will be the same type only. Now there are different techniques of differentiation. All the basic derivatives, I think all of you must be thorough with all the basic derivatives, because in 11th class you have studied the standard derivatives of all functions: sin x, cos x, tan x, all trigonometric functions, logarithm, log x, e raised to x, like that. Okay. So please remember all those standard formula and the product rule of differentiation, and also the quotient rule of differentiation. So these 2 methods of differentiation, all of you have discussed, studied in the 11th class actually. Now in 12th class, the syllabus of differentiation starts from the chain rule actually, chain rule. So what is the chain rule? Suppose we have a function sine of cos x. Okay, f of x equal to sine of cos x. Here y is equal to sine of cos x. So here you can see there are 2 functions actually. No? One is sine function, other is cos function. So it is called a function of a function. Okay, chain chain of two functions actually. Function of another function. So how to differentiate? Yeah, how to find the derivative of this function? For that, we apply the rule which is called chain rule. For function of a function rule. Another name is function of a function rule. Okay, chain rule, yeah, function of a function rule. So what we have to do is, in the beginning, what we will do is, in the bracket, that function, we will put some new variable, new name. So we put the bracket, inside the bracket function as some u. Okay, the cos x, you take it as u. So our given function y becomes sine u, sine of u. And remember, what is u also? What is u? U is cos x. U is cos x. Then we differentiate each. Y is a function of u. Y is sine u. So y is a function of u. So dy by du. Derivative with respect to u. Dy by du means d by du of sine u. Derivative of sine u with respect to cos u. Sorry, with respect to u. That is cos u. And the next function is u. U is a function in x. U is a function in x. That means we have to find derivative of u with respect to x. So du by dx, and that's equal to minus sin x. All of you know the basic formula of differentiation. So please make it thorough. So we got dy by du and du by dx also. Okay. Now the chain rule. Actually, we have to find dy by dx. Okay. Our aim is to find dy by dx. So for that, the chain rule will help. So chain rule says that dy by dx is equal to dy by du multiplied by du by dx. Dy by du multiplied by du by dx. How it comes, etc., is beyond our syllabus, beyond our discussion. So just you remember this formula. Okay, it's just like cancelling du and du, but it is not actually cancelling, but just I am telling. Just like in that way, you can imagine. Okay, du and du cancel, mean remaining is dy by dx. So in that way, you can connect. So now what is dy by du? Dy by du means cos u. And du by dx means minus sin x. Now, again, u is a temporary substitution. So again, we have to bring back into x actually. Okay, so what is u actually? U is cos x. So cos of cos x into minus sin x. So minus can be written in the beginning. So this is the answer for our derivative of sine of cos x. Okay, derivative of sine of cos x is obtained by chain rule, and the answer is minus of cos x into sin x. Okay, it goes like a chain. That's why it is called a chain rule. Now suppose there can be a function which is a composition of 3 also. Sine of cos of x square. Sine of cos of x square. So what we can observe here, this is a composition of 3 functions. Okay, you identify the 3 functions first. First one is sine. Okay, then cos. Here there is no x actually. Okay, sine of cos of x square. Okay, sine of cos of x square. So there are 3 functions. One is sine, other is cos, and the third one is x square. Okay, the inside the bracket you can see x square, just outside cos, then outside sine. So there are 3 functions actually. So again we have to apply the same rule. Each function we have to put some name. So what we will do, we put x square equal to some u or w or v, whatever it may be. Okay, put x square equal to u. Okay, then this becomes sine of cos of u. Okay, sine of cos of u. Okay, again, the cos u, we can put some another name, say v. Okay, if I put x square equal to u, this becomes sine of cos u, and cos u I have taken as v. Then it becomes sine of v. Okay, cos of u means cos of x square, and cos of u equal v also. So sine of v. So our actual original function reduces to what? Y is equal to sine of cos x square. Cos x square is actually v. Okay, y is equal to sine v. And what is v? V is equal to cos u. And what is u? U is equal to x square. Okay, so y is equal to sine v, and v is equal to cos u, and u is equal to x square. The variable you can put anyway. X square also you can put a v, cos v you can put u, no problem. Okay, now there are three functions: sine v, y is sine v, v is cos u, and u is x square. We all differentiate each and every one. So first we will find the dy by dv, because y is a function of v. So dy by dv means derivative of sine v with respect to v. That everybody knows. What is the answer? The answer is cos v. Okay. Now let us find dv by du. dv by du. V is a function in u. V is a function in u. So we will find dv by du. That means d by du of cos u. d by du of cos u means minus sine u. And the third one, the last one, u is a function in x. So find du by dx. U is a function in x. So find du by dx. That is 2x. So there are three functions actually. Now we have to multiply as in the earlier. We have to find dy by dx. Okay. So dy by dx can be written as multiply all the three. dy by dv into dv by du into du by dx. In order, you multiply dy by dv into dv by du into du by dx. So dy by dv means cos v. Substitute each and every value. And dv by du means minus sine u. And du by dx means 2x. Okay. So cos v into minus sine u into 2x. So this can be again brought back into our original variable. So if minus is there, you can put in the beginning. If any number is there, constant is there, that also can be written in the beginning. So minus 2, right in the first, and again x is there, x also can be written in the first. So minus 2x into cos of what is v? What is v? v is equal to cos u, and u is equal to x square. That means cos of x square into sine u. Sine u. What is u? U is x square. So sine u means sine of x square. Okay. So this is the answer for our which function? Sine of cos of x square. So this is actually chain rule. In detail, we will do like this, okay, in detail. But after continuous practice, I think there is no need of elaborating like this. We can write the answer in a shorter way also, okay. You just identify the three functions first. There are three functions. One is sine, other is cos, and third one is x square. So the outermost function, that is sine, okay. So you know what is derivative of sine? What is derivative of sine? That is cos. No? So just you apply the derivative of sine. The remaining thing as it is, okay, no change. Only apply the derivative of the first one, that is derivative of sine is cos. That means we can write cos of the remaining as it is. Cos of x square. Okay, multiplied by into. Now you forget about sine. Remaining is what? Cos of x square. Cos of x square. Now derivative of cos apply. Derivative of cos means minus sine. So minus sine of x square. Minus sine of x square. Derivative of cos is minus sine. So minus sine of x square. Now we have applied derivative of sine and also cos. The remaining is, the last one is x square. Okay. So what is derivative of x square? That is 2x. So multiply 2x. Okay. So if you write it in order, you will get the same. Minus 2, right in the beginning, minus 2x. Okay, minus 2x, then cos of x square into sine of x square. The same thing. Minus 2x into cos of x square into sine of x square. Okay. So in this way, we can practice and make it thorough. So y is equal to e to the power minus x square plus 2x plus 1. So you can see it is the composition of two functions here also. One is the exponential function, e raised to x form, e raised to something, e raised to x form. And in the exponent part, you can see there is a polynomial function. Okay, so there are two functions actually. So if I apply the actual method, what we have to do? Put u is equal to minus x square plus 2x plus 1. Okay. Therefore, our y becomes e minus x square plus 2x plus 1. Isn't it? Our given function y, that is equal to e raised to u. And what is u? U is minus x square plus 2x plus 1. Then as earlier, let us find dy by du. Y is a function in u. Y is a function in u. So we have to find dy by du. So what is dy by du? You know, derivative of e raised to u means e raised to u only. D by du of e raised to u is e raised to u. D by dx of e raised to x is e raised to x. E raised to x is the only function which will give the same function after differentiation also. No change at all. And du by dx. What is du by dx? Du by dx equal to minus 2x plus 2. Minus 2x plus 2. So multiply. Therefore, our final answer, the dy by dx is equal to dy by du means e raised to u multiplied by minus 2x plus 2. Okay. That can be written as minus, if you want, you can write the algebraic term in the beginning. Minus 2x plus 2 into e raised to u. U means the same thing. Minus x square plus 2x plus 1. This is the answer. Okay. So this also can be done directly without any substitution. For that, the same technique. There are two functions actually. One is e power x function, other is minus x square plus 2x plus function. Okay. So first apply the derivative of e raised to x. You know, derivative of e raised to x means no change as it is. E raised to whatever the value given here. So e raised to minus x square plus 2x plus 1. Apply the derivative of e raised to x. Now multiply derivative of minus x square plus 2x plus 1. That is minus 2x plus 2. Minus 2x plus 2. Okay. So in this way, you can directly write the derivative. So that's about chain rule. Okay. This can be extended for any number of composition of functions. Okay. Same thing. It will go in the form of a chain. That's why it is known as the chain rule. Now, what is the next topic in our 12th class syllabus? The derivative of inverse trigonometric functions. Okay, derivative of inverse trigonometric functions. That I am not going to discuss because that is very simple, direct questions only. For example, y is equal to sine inverse x. Y equal to sine inverse x. So how to find the derivative of sine inverse x? Better to write in another way. Y is sine inverse x means, you know, x equals sine y. Y is sine inverse x implies x equal to sine y. Okay, so apply the derivative. We differentiate with respect to y. So dx by dy. So what is dx by dy? That is d by dy of sine y. So dx by dy will become cos y. Okay. So dx by dy is cos y. So dy by dx will be 1 by cos y. Dy by dx will be 1 by cos y. But the answer should be in terms of x only. Okay. So we have to bring back the result into x in terms of x. So what for that we can write this cos y as 1 root of 1 minus sine square y. Okay. Now what is sine y? Sine y is x. Sine y is x. So sine square y means x square. So you will get dy by dx equal to 1 by root of 1 minus x square. So all the trigonometric, inverse trigonometric functions, the derivative can be find out in the same procedure. So I'm not discussing about the other functions because all these are standard formula. You might have studied also. But please remember all these formula, make it thorough. Now we will go to the next concept, next topic of this chapter, that is the derivative of implicit functions. Okay, derivative of implicit functions. Implicit functions and explicit functions. So far we have discussed the functions which are very clearly expressed in terms of x. Yeah, y is explicitly expressed in terms of x. Y equal to x square. Yeah, y equal to e raised to x. Yeah, y is equal to sine x. Okay, yeah, y equal to sine of cos x, whatever it may be. X and y are separated actually, no? Y in terms of x. So this kind of functions are known as explicit functions. Okay, here the derivative can be found out very easily by differentiating without any problem. But some functions may not be like this. Okay, we cannot separate x and y. For example, x square plus xy plus y square equal 1. So can you separate y and express in terms of x? Is it possible to express y in terms of x? It's not an easy task actually. So there is no need of doing like that. And this kind of functions is known as actually implicit functions, okay? Any function of this type, where x and y are coming together. Okay, y cannot be expressed, yeah, x cannot. So in this case, how to find the derivative? How to find dy by dx? This kind of function. That is known as actually implicit differentiation. For example, I will take x square plus y square plus xy is equal to 1. X square plus y square plus xy equal 1. Okay, this is an implicit function. So how to find the derivative? Means we have to find dy by dx. The question is find dy by dx. If x square plus y square plus xy equal 1, find dy by dx. What will do? So what we have to do here, we differentiate each and every term with respect to x. Okay, differentiate each and every term with respect to x first. So first term is x square. So derivative is 2x. So differentiating with respect to x. The first term is x square. Derivative of x square with respect to x is, that is 2x. And derivative of y square with respect to x. Derivative of y square with respect to x means that is 2y into dy by dx. So in this step, we have to be little careful. Okay. Derivative of x square, we are differentiating with respect to x. Okay. So remember, d by dx of x square is 2x. D by dx of x square is 2x. In the second term, what we are doing is d by dx of y square. D by dx of y square. Okay. So differentiation is with respect to x. So it is 2y? No. It is not only 2y, it is 2y into dy by dx. How it comes actually? Using chain rule only. Okay. So d by dx of x square, I can write in this way. I can modify d by dy of y square. Okay, I will change the dx as dy into dy by dx. D by dy of y square multiplied by dy by dx. Okay, chain rule actually. Derivative of y square means, 2y. Next step. Okay, 2y, and the derivative of y with respect to x means dy by dx only. Dy by dx, no change. Dy by dx. So this is the step you have to be careful in this step. Sometimes many students commit mistakes here. They forgot to write the dy by dx term. They simply write dy by dx of x square is 2x. Okay, no problem. D by dx of y square is 2y. That is wrong. D by dx of y square is 2y into dy by dx. Okay. Differentiation is with respect to x. Okay. The function variable is y. So derivative of y with respect to x, we have to multiply. Okay, then the next term. The next term is, what is the next term? The next term is xy. Next term is xy. So derivative of xy. There also, you need to be little careful. What is derivative of xy? The next term we have to write is derivative of xy. What is d by dx of xy? So there you have to apply the product rule. Okay, x into y. It's the product of two terms, two functions actually, two variables, x and y. So apply the product rule. What is the product rule? The first function into derivative of second means derivative of y. That is with respect to x. So dy by dx. First function is x into derivative of y means dy by dx plus second function. Second function means y. Y into derivative of first. Derivative of first means derivative of x, that is 1. So y into 1. That is equal to, we have to differentiate each and every term, okay, from both sides. So right side also some term is there. The right side is 1 actually. That means right side part is 0. Derivative of any constant is 0. Okay. So differentiation part is over. Now what we have to do is collect all the dy by dx terms together. Our aim is to find dy by dx. Our aim is to find dy by dx. Okay. So what we have to do in dx. So you can see what 2y dy by dx is here. 2y dy by dx. Keep it here only. And one x dy by dx. X dy by dx. And the remaining thing, all the remaining terms, shift on the right side. That means minus 2x minus y. Now dy by dx is common. So take it outside. So 2y plus x into dy by dx is equal to minus 2x minus y. Now we how to find dy by dx. So only keep dy by dx here. What is the term in with the dy by dx? 2y plus x. So that should be taken to the right side. That means minus 2x minus y divided by 2y plus x. So this is the value of dy by dx. Okay. So answer also contains x and y both together actually. No problem. Another example. Let us take another example. X square plus y square equal to sine of xy. Find dy by dx. X square plus y square equal to sine of xy. So find dy by dx. Here also same thing. It is an implicit function. We cannot separate y and x. We cannot express y in terms of x. So it is an implicit function. So the same procedure, differentiate each and every term with respect to x. To differentiate each and every term means derivative of x square with respect to x means 2x. Derivative of y square, that is 2y dy by dx. Remember, 2y dy by dx multiply dy by dx. Don't forget. Okay, then right side. The function is sine of xy. Sine of xy. Okay. So what you can observe? It is a function of a function. Sine of xy. And not only in bracket x and y, a product is also there. So please take care of all these things. Okay. So apply the chain rule first. Means derivative of sine. Derivative of sine means cos. Derivative of sine xy means cos xy. Not finished. Okay. Into what we have to do? Multiply derivative of xy, dy dx of xy. Okay. So we have differentiated each and every term. Derivative of x square is 2x. Derivative of y square with respect to x is 2y dy by dx equal to derivative of sine xy means cos of xy into d by dx of xy. So we need to differentiate this portion again. So better to do step by step. So what is the next step? Left side is okay. Only the right side portion we have to modify further. So cos of xy into d by dx of xy. What is d by dx of xy? Again, apply the product rule. X into y means product of two functions actually. So x into dy by dx plus y into 1. Derivative of x is actually 1. So d by dx of xy. X dy by x plus y. Okay. Now the differentiation part is over. Okay. We have differentiated each and everywhere, wherever required. Now the next task is we have to find dy by dx. For that, we have to collect the dy by dx terms together in one side. Okay, so in the right side, you can see there is a bracket. That bracket, remove it first, then take the dy by dx in the left side. Okay, that means already we have 2y dy by dx in the left side. So write it as it is, write as it is, 2y dy by dx. From the right side, you will get cos xy into x dy by dx. That means x cos of xy into dy by dx. Okay, x cos of xy into dy by dx equal to the remaining terms. Whatever the remaining terms, just shift to the other side. Okay, that means 2x will become minus 2x and already here we have y into cos of xy. If you remove the bracket, okay, cos xy into y will be there. So okay, the remaining thing is very simple. Just to take the dy by dx term in outside. So if I take dy by dx outside, inside the bracket, what will be 2y minus x into cos of xy. That is equal to the right side as it is, minus 2x plus y cos of xy. So dy by dx will be equal to minus 2x plus y cos of xy divided by the bracket term, that is 2y minus x cos xy. Okay, so this is called the implicit differentiation. Okay, and more problems we will discuss later. Now the next the next method is logarithmic or differentiation. Logarithmic differentiation. Logarithmic differentiation is differentiation using the properties of logarithm actually. Okay, log function. There are some standard properties of this log function, so we have to apply those properties for doing the differentiation. Okay, so I know all of you are familiar with this log function. What is the meaning of a log function? F of x is equal to log x. When I write f of x equal to log x, it is understood that the base of this logarithm is e. Okay, this is the natural logarithm. F of x equal to log x, whatever the log x, what we have, what we are using in our textbook, etc. Be any logarithm can be of any base actually. Okay, log x to the base 3 also. It is another function actually. Log x to the base 3. Yeah, log x to the base 10. When the base is 10, we call it as a natural logarithm. And logarithm and the exponential functions both are inverse of each other. You know, if log x equal y, log x to the base e equal to y, then which implies that e raised to y is equal to x. So logarithm and the exponential function both are inverse of each other. Okay. Similarly, suppose the base is some other number. Okay, base can be any number. Suppose I say log x to the base 3 is equal to some y. Log x to the base 3 is equal to y, which implies that 3 raised to y is equal to x. So for exponential function also, the base can be any number. Okay, here the base is 3 actually. The logarithm base is also 3. Okay, but in our mathematics, we are using two standard logarithmic functions. One is the natural logarithmic function and the other is the common logarithmic function. Okay, natural logarithmic function means the base is e, is a mathematical constant. Around the value is 2.7 something, and the corresponding exponential function, we call it as a natural exponential function. Okay, so you must know the domain and range also. Okay, what is the logarithm domain? The logarithm is defined only for the non-zero real numbers, means positive real numbers, 0 to infinity. Okay, domain is 0 to infinity. Because log 0 is not defined. Okay, log 0 is not defined, and log negative 1 is not defined, log negative 2 is not defined, etc., etc. Logarithm is defined only for all the positive real numbers only. Okay, and the range is all the real numbers. Okay, so please remember the domain and range of this logarithmic function. And the exponential function. Exponential function is the inverse. Exponential function is the reverse, a inverse function of the logarithmic function. So naturally, it must be a function from R to 0 to infinity. Okay, please remember the domain and range. Okay, so logarithm is defined only for positive real numbers, and the domain is, sorry, range is all real numbers, and exponential function is the domain is all real numbers, and the range is positive real numbers. And logarithm has some properties, and that properties can be used to find the derivative of certain functions. Okay, that we will discuss, I think, in the next session. Now the time is already over. Now I will stop here, and if you have any queries and questions, you can ask me now. And we will meet again at 2 p.m. Okay, at that time you can bring with your queries and questions or any problems. Okay, by 2 p.m. 2 to 3:30. If anybody is having any doubt or any question or anything you want to talk, you can mute your mic, unmute your mic and ask. Any questions? From JNV Karakal. I'm not hearing any voice actually.
What is the afternoon
Eh?
class? Afternoon class is about which topic?
Same thing, na? I'm not hearing any voice actually. If anybody is asking any question? Oh, can you teach again natural logarithmic function? Okay, I will do it. Okay. Now the time is already over. That's why. I will discuss again in logarithm and exponential function with the graph, etc. Okay. Anyone? Any others? Any?
Inform them that the video is uploaded on YouTube.
Okay.
They can watch it anytime. In JNV
And also this video is already recorded and this is available. Okay. At any time you can watch actually. Later also you can watch in YouTube also. The same video is available. If anybody is having any query, please put it in the comment box. Otherwise, in the afternoon, you can come with your doubts and questions. Okay. Afternoon from 2 to 3:30. Okay, then we will stop here. Okay.